Hi students, now let us discuss the nonlinear partial differential equations type 2 or the standard form 2. So what is the standard form 2 means? Here if the equations, the nonlinear equations in the form of f of z comma p comma q is equal to 0. Okay, that is the terms contains only z p q. Okay, not containing x and y. There is no x and y, only the terms should contain z p q. Okay, now let us follow what is the working rule to solve this type of nonlinear equations. Okay, that is the equations contains only z p q is equal to 0. In this case, for the first step we have to follow, first we have to let the solution. Okay, see here, let the solution be z is equal to f of u. Okay, we have to assume the solution as a function of u. But what is u here? What is u? We have to assume that let u is a some function of x plus ay. Okay, x plus ay, and substitute here p is equal to small p. Okay, p is equal to dz by du and q is equal to a into dz by du in the given equation. So that is in this. Okay, but how we got this p as a dz by du? Since we know that what is small p is dou z by dou x, so this can be taken as a dz by du into dou by dou x. See here, z we have just assumed as some function of u in between of z and x. Okay, z we just assumed as a function of u, and where u is a function of x and y. U is a function of x and y. Okay, so now here then we have to get what is the dou z by dou x. That we have to go through u, dz by du into dou u by dou x. Why dz and dou u? Because here z is a dependent variable and it's a function of only single independent variable. That's why we are using ordinary derivative for this dz by du. And but here u is a function of two independent variables. That's why we are using dou here. That is partial derivative. This is ordinary derivative here. So therefore, small p is equal to dou z by dou x. That is equal to dz by du into dou u by dou x is equal to dz by du. And q is equal to dou z by dou y. So that is dou z by dou y means we have to go through u here. So that means dz by du into dou u by dou y. Okay. Now to get the dou z by dou y is equal to dz by du into dou u by dou y. What is the dou u by dou y? Here from this dou u by dou y is a. And here also dou u by dou x is 1. Okay, that's why we are getting p is equal to dz by du and q is equal to a into dz by du. Okay, now the step 2. Now after reducing the given equation, that is f of z p q, by substituting this p is equal to dz by du and q is equal to a into dz by du, the resultant, this equation will be in the form of ordinary differential equation. That is only in terms of z and u, where z is a dependent and u is an independent variable. Okay, only in terms of z and u. So that is the ordinary differential equation. Now we can follow this substitute that after solving this ordinary differential equation we will get final solution, and then the step 3 you have to substitute in place of u x plus ay. So that gives the final solution of the given non-linear equations of this form f of z comma p comma q is equal to 0. Okay, let us do one problem here. Okay, let us do one problem. Here is the problem here. Solve z is equal to p square plus q square. Solve z is equal to p square plus q square. Now the given equation, so you can observe this problem contains only p q z. Okay, so this is of standard form 2. Okay, this is of standard form 2. Now you can see here which is of the form f of z comma p comma q is equal to 0. Now what is the procedure? First we have to assume the solution. Let z is equal to f of u. Okay, let z is equal to f of u, where u is equal to x plus ay with a solution of 1. Now substituting p is equal to dz by du and q is equal to a into dz by du. Okay, p is equal to dz by du and q is equal to a into dz by du in 1 in the equation 1. So we get z is equal to dz by du whole square plus a square into dz by du whole square. Now what is the common in this step? The final step, dz by du whole square is the common. We can take the common. There you will get z is equal to 1 plus a square into dz by du whole square. Now we can have here dz by du is equal to root over z by 1 plus a square. Okay. Now separating the variables separable. Okay. Separating the variables, we get dz by root z is equal to du by root over 1 plus a square. Okay. Now integration. Do the integration on both sides. Here the dz coefficient as z du it's a constant. Okay. Integrating 1 by root z integration is 2 root z and here u plus c. So 2 root z is equal to, what is u? Just we assume u is a x plus ay. So substitute finally once you got the solution of the ordinary differential equation. Okay, once you got the ordinary differential equation solution, substitute that u, what is u? X plus ay. Substituting this, we'll get squaring on both sides. We get z is equal to x plus ay plus c whole square by 4 into 1 plus a square, which is the required solution. Okay, now take a look at another problem. Solve z square into p square plus q square plus 1 is equal to 1. Okay, now the given equation is this. The same, the equation is of the form f of z comma p comma q is equal to 0 form. Okay, now what we have to do? Let us do the same procedure. Let z is equal to f of u, where u is equal to x plus ay be the required solution. Now substituting, small p is equal to dz by du and small q is equal to a into dz by du. Okay, substituting in 1, we get, this is what you will get by substituting in 1. Z square into dz by du whole square plus a square into dz by du whole square plus 1 is equal to 1. And plus if you take that z square, you multiply z square, take to the right side, take it to the right side, 1 minus z square. Now in these two terms, so what is the common? Dz by du whole square, z square is already outside, 1 plus a square is equal to 1 minus z square. Okay, now you can see if I go through this one, the whole square, if I take this to the right side and if I take it to that, it will become square root of 1 minus z square by this 1 plus a square, square root of 1 plus a square it will be. Okay, now separating the variables, z terms and u terms on another side, some constants. Here the constant is root over 1 plus a square. Z terms separating, z by root over 1 minus z square dz is equal to u by root over 1 plus a square. Okay, so now multiplying and dividing by minus 2, because the derivative of 1 minus z square is minus 2z, but z is there but minus 2 is missing. That's why we are multiplying and dividing by minus 2. So here you can observe the derivative of this we have in the numerator. Okay, so now we can integrate this. We can integrating this one. Yeah, integrating we get so this is minus 1 by 2 and 1 by root z. Okay, 1 by root z derivative will be 2 root z. Okay, so here like this, here the z is means here is the inner function, 2 root 1 minus z square is equal to here u plus integral constant. Okay, so now here we will getting this 2 get cancelled, this minus 1 minus z square whole by 1 by 2. So just replace u, what is just we assume x plus ay, so x plus ay plus c. squaring on both sides. Yeah, this 1 plus a square I took it to this side. 1 plus a square into 1 minus z square is equal to x plus ay plus c whole square, which is the required solution. Okay, I hope you understand. Yes, thank you.